What's going on here, guys? Figured I'd give a quick demonstration and a quick explanation of everything going on, how the system is built, sum it up real quick. So the main coil we're using as our output coil for everything you see in the videos, this is the coil that is giving us all of our power. It is, I believe it's one of the most efficient ways to wind a coil. It's Nikola Tesla patent 336961. That's how our coil is wound. We have 3 Schottky diodes on it. One comes off one leg, the other comes off the other leg. They're combined, their outputs are combined, and we have another Schottky diode here, and we use that power output. I'll show that on one of my cleaned up ringer circuits that power the generator boards for the rapid recharging of batteries. So here's how one of the cleaned up models look. I will remove my wires. These were the wires that were tapping the power off the output, so hopefully you can see that. I'll try and hold the camera nice and still so you can see it. I wrapped the aluminum heatsink in insulative Kapton tape so nothing shorts out, and I carve a little space out so the transistor can sit there. This will basically be an explanation video, a full schematic video how to build it. It's pretty simple, takes a bit of work though. So yeah, I'm giving you a good look at how the yellow coils look. Zoom right in, show you. And you can see how the diodes come off. Those are 3 SR560 Schottky diodes. The ferrite rod is 6 inches long. I use type 77 metglas laced for a small boost in performance. Don't have to use metglas, I just like having the most efficient advanced materials available to use. I sold out all mine. They're selling like hotcakes. I'm waiting for my new large bulk shipment to come in of them. So it's 6 inches long. I leave a 1-inch space on each end to wind the coil. All coils are 4 inches long, except for the outermost Tesla coil. That's wound per Tesla patent 336961. It's technically two coils, each one 2 inches long. Well, you could say it's one. Well, no, it's technically 2 coils because one's wound the opposite direction. They both share a center tap, though. But yeah, you want your coils to be exactly the way I construct them and describe for the utmost efficiency. Everything has to be a multiple or divisible of each other. If you decide to variate from my exact construction schematics, you want the wireless power to talk to each other at the most efficient, effective frequencies. And to do that, you build your receivers or coils identical to each other, or a multiple or divisible of each other's length or width. Or you can make them equal in mass to each other, or a third wide as they are long. So yeah, going on to the next page. My circuit is, you can use, it's a modification of the Laser Saber's Super Joule Ringer 3.0 circuit. The exceptions I made as notes right here. So you can follow this schematic exactly and follow the notes. I improved upon it. So Laser Saber or Laser Hacker was the original inventor. I've just simply improved upon it with new concepts from a couple of old textbooks, Tesla textbooks, and the main thing being negative resistance and decoupling cause from effect within the system. So give you a good look at everything and we'll give it a quick rundown. The first modification I made is we're using a 4-inch by 5.5 inch, well, that should say 6 inch, 0.4 inch by 6 inch ferrite rod, type 77 metglas laced. You could use the 5.5 inch, but when you construct the coil, you leave equal distance on the ends when you construct it for the best performance. Tip 35C transistor was the next modification. Third modification, it's mounted on a heat sink so we don't generate too much heat. Fourth modification, it's drilled and tapped. That's what holds the transistor in place right there. You can just unscrew it, easily swap it out if you blow a transistor. And that's with a set 440 drill and tap set, number 43-8029. I mean 8209. Number 43-80209. Cold cathode neon bulb, the most recent modification. I get mine in bulk from Ukraine. Only place you can get them apparently lately is Ukraine or Russia. Any neon bulb will work, but I get the special ones which have their cold cathode effect really emphasized, so I found that helps a little bit, improves efficiency. Like I said, you don't need the cold cathode enhanced version of the neons, and you don't need the metglas laced ferrite rod. I just have them because I want the absolute best you can get. So moving on to the output coil. This is the schematic for the yellow output coil. It should be pretty straightforward how it's made. It's made with 18 AWG stranded yellow wire. That's the inductance off of both of them. They're identical coils. You would take the coil, measure it out, make the lengths identical to each other, and cut them. It's technically one long length of wire that measures 4 inches long when wrapped on your 6-inch metglas rod, and you just cut it in half, perfectly even. I can't talk. The more identical the wire lengths are to each other, like if you cut it dead even in the center, it'll perform the best. So you want to construct everything as cleanly as possible. Like you can see, the two outputs have their positive outputs combined, and the center would be your negative. And again, we'll give you a look at that. You can clearly see the two yellow outputs from the coil on each end, the diodes that are connected, the SR560 Schottkys. Zoom right in on it. And yeah, that's how the center looks. So we have 3 diodes total. This is the return. This coil will put out about 60 volts, anywhere from 1 to 3 amps, depending on how you ground the system through your through either your spark gap or your cold cathode neon or your regular neon, or however you decide to ground it. When you ground it, you're trying to focus on something that adds non-linear effects to the circuit, or a type of plasma into the circuit. So moving on, this is the exact ringer circuit I'm using. This is the negative resistant ringer circuit, which would be this, because we don't, the modification we did from Laser Sabers is his output, the power output from his circuit runs light bulbs directly. But the thing is, we don't want to do that because we want to keep our input power as minimal as possible. And the idea and theory behind this is we create a negative resistance circuit by closing it. So we use the correct value carbon film resistor. Has to be carbon film. Wire wound resistors will detune everything you're trying to do. So you have to use carbon film resistors. This is a 1 nanofarad capacitor in parallel with the 3 carbon film resistors. Each one is a 30K carbon film resistor, 3 in parallel to form a negative resistance network. And I discovered you can achieve the negative resistance without also having the bulb in parallel here. It's just a matter of the correct value resistor and capacitor to create negative resistance. Along with that earth ground connection. So yeah, to sum it up, it's the negative resistant ringer circuit. instead of running loads directly off of it like Laser Hacker does, his high frequency output runs his loads directly. The improvement or modification we made is we don't run the loads directly, we close the circuit and we make a resonant negative resistant RLC circuit. So I'll repeat that. It's a negative resistant resonant RLC circuit. So once that circuit is established, we don't want to drain that circuit's power. That circuit it's isolated, we don't touch it. It's technically an open system when you earth ground it. We're maximizing nonlinear effects in it with the plasma bulbs we use. So we then, because this is a wireless coil, and we're trying to introduce gain into the system, that's the theory behind it, we're trying to introduce gain into the system in our negative resistant RLC circuit, which I just talked about, and we try and tap into the extra power that circuit gains from the ambient environment. We tap into that extra power wirelessly with that yellow Tesla coil, the 336961 patent. And when you tap into it resonantly and magnetically, you virtually drain no power. You achieve the decoupling effect, the negative resistant effect, and the very fast resonant recharging effect of batteries. The newer your battery, the quicker it can recharge. Like if you use an old lead acid, it'll recharge a lot slower compared to a what is this? One of these like hybrid super capacitor Lifey PO4 batteries. So the newer your battery tech, the quicker you can charge and discharge your devices. The end goal is your high frequency output from this yellow coil can rapidly recharge batteries and devices that then run a 120 or 240 volt AC inverter for a time. So again, here's a good look at the schematic. That's my exact schematic. You can pause it on that if you'd like, and then we're going to discuss it. So, I'm going to try and hold this still. The only thing that's missing in the center here is the ferrite rod. That's all that would be there, is the ferrite rod, the 6-inch ferrite rod. Your L1 coil is... I just don't want to do any retakes of this video, so I'm going to give you the exact value on what the L1 coil is, so there can be no mistakes. This is going to be a perfect video. The L1 coil is 26 AWG. The L1 coil, oh, it's even said on the schematic. So the L1 coil is 26 AWG. The L2 is 14 AWG. The L1 coil is wound first because it's the thinner coil. The L2 is wound opposite to the L1. The L2 has to be wound opposite to the L1 and is a bucking coil. If you wind it in the same direction, your circuit will blow up and it will not work. You'll be lucky if it just doesn't work. Most of the time it just blows up. So your L1 and L2 have to be in a oppositely wound bucking configuration. And your L3 coil, the yellow Tesla one, wound per patent 336961, that has to be wound the same direction as your L2. I don't exactly know why that is, but it has to. I'm not sure if I stated that correctly in the PDF. If not, I have another free version of the PDF coming out that will be more detailed and explain that. But just from this video alone, you should be able to fully construct and replicate this system. Like I said, I'm an open source research company. I hold nothing back. I sell the units just as a matter of convenience for people who don't have the time or don't want to put the effort into building it themselves. They can just buy a pre-made unit for experimentation. And technically all these units are experimental and made for experimentation. So yeah, I don't hold anything back. Everything is fully disclosed. I'm not hiding anything behind paywalls. People can feel free to support me if they wish or not. I list everything for free on my Patreon. I also have an archive of ancient electrical engineering knowledge on it, all compiled in one place, all for free. I hold nothing behind paywalls. True knowledge is free for everybody. The schematics are there. I simply took old and existing technology, kind of simplified it, compiled it into one, had a few interesting ideas to try, and it seems to be hyper efficient. This work is the extension of many others who came before. So, and like I said, nothing's held back, nothing's suppressed or locked behind a paywall. If you go out in public, I mean, I have a lot of people complaining, telling me I should give stuff away for free. What company on the planet gives away anything for free? I mean, people are lucky you get the full exact schematic. I don't even charge for that. Completely free schematics, nothing held back. No company on the planet will give you a battery for free, a solar panel, a generator. There's not one thing on this planet you can get for free. So, the people complaining that it should be free, I don't know what else you want. You literally have the schematics to build it in this video and on the Patreon for free. So yeah, that's how it looks. I'm powering this up off a 14 volt, 5 amp hour Life EP04 battery. It's a supercapacitor hybrid Life EP04 battery. Passes through an amp meter so we can read the current draw. The odd thing is, because I believe pulsed DC is coming out of these coils, is you can't read the current draw that a load is drawing when you put the meter, an amp meter, in series while you're running a load. So yeah, we'll look at the schematic again. Well, this is the schematic for the yellow coil, the Tesla coil. This coil, we're only using the top one here, we're not using the bottom ones, we're just using this, the 336961. And we just have a Schottky diode coming off here, Schottky, and again, another look at the notes. Feel free to pause it. There's no reason why anyone can't replicate this now. Even if you don't use the materials I use, you can still replicate it and have pretty good results. Another look at this. This is my exact circuit. And this stands for cold cathode spark gap discharge tube. The 1 nanofarad capacitor is in parallel with the 30K resistor network. The only thing not shown here is if you want a higher output, you might need to put 3 30K 5-watt carbon film resistors in parallel with each other for a higher output on your yellow Tesla coil. And when I say yellow Tesla coil, I mean the 336961 Tesla coil, not a incorrectly built Tesla coil that just shoots sparks. Real Tesla coils that academia twisted are giant, incorrectly built spark machines. I believe they're called Odin coils is the real name. So, anyway, a real Tesla coil is as wide as it is tall. I believe for the most efficient conduction of wireless power, you want your coils to be a third wide as they are long for your transmitter and receiver, and heavily earth grounded. But anyway, we're talking about the negative resistant super joule ringer. So hopefully you can see that really well. These resistors are just these are three 30K resistors in parallel with a 1 nanofarad capacitor, ceramic capacitor. Each resistor is 5-watt carbon film. We have 3 in parallel, and it's a negative resistant network. I found that seems to really help. And again, we're tapping that power wirelessly and resonantly with the coil here. Give you a look underneath it, perhaps. But yeah, I'm gonna turn it on now and show you. I don't believe I missed anything. I'll show this again. You can pause it on it. We'll go through the whole thing just in case. You power it up with a 14-volt source, and I have the current passing through an amp meter so we can read how much is drawn with a switch. You don't want to energize it past 14 volts DC. The base of the transistor will blow up. Here's how the coils look. Your L1 is 4 inches long and is 26 AWG, highest quality magnet wire you can get. The cleaner you build it, highest quality your materials, the better. Your L2, 14 AWG, again, very high quality wire. And the L1 and L2 are wound opposite to each other. They're wound in a bucking configuration. They have to be. If it's not, your circuit will blow up. And the L3 coil, the Tesla's 336961 coil. So this one, that coil that gives us our power, that yellow one, has to be wound in the same direction as our L2 coil, which you can see underneath here, the red one. I'm thinking of renaming these to the red ringers. So again, L1 and L2 wound opposite to each other. L3 is wound in the same direction as the L2. And you can have a good look at mine, the directions they're wound in. There's no reason someone can't easily replicate this now. So next, we will power it up. I'll power it up with my battery, and I'll also power it up with my power supply and show you some interesting discoveries. So I'll turn the circuit on, and you can immediately tell it's on because it gives off wireless power. And for those that doubt the wireless power is coming from the circuit, I can switch it off. The wireless power is immediately out. I'll try and display that again. I'm not exactly sure how the coil can generate such effective wireless power like that. I believe it's coming from the yellow coil. So anyway, it's on. We can tell it's on by this little detector, Arvomenko style. Just 2 diodes in a pigtail configuration with an LED light. 1 N4148 diodes. The RF version would be the most efficient. So the circuit is on, it's live. I'm then going to connect up my LED lights. So there we go, it's extremely bright. And this is the part where it gets interesting. As you see, this is our power draw on the circuit. The load, when we run the load, because we have negative resistance, we run the load and it causes us to consume less power. So that's how you know you constructed the circuit correctly, is when you run the load, your circuit consumes less power. Now that's very beneficial to you, because if you put this in a rapid charging pulse circuit, you can rapidly charge large capacitors, and when you do that charging effect, you're basically recharging these large capacitors in these large storage mediums at less of a power draw to you. Usually when you draw power from a source, your input increases, but in this case, because of the effects I spoke about earlier, our power draw decreases, which isn't a normal phenomenon that we're taking advantage of. So again, it's theorized we have a negative resistance effect occurring. So that's very bright. If I short this out, which you can't do for too long, your diodes will melt. These are 5 amp rated diodes, the SR560s. If I short this out, you'll see my input power drop to almost nothing. Now that's not a normal phenomenon that's occurring. I'll leave it dead shorted and show you we still have wireless power, which of course is also not a normal phenomenon. And I can't leave that shorted too long. I don't want to burn the diodes out. And if you try and take a power or voltage reading on the yellow coil without the diodes, the fast switching Schottky diodes that you need you won't be able to read anything. The power is undetectable and unreadable without the addition of those diodes. Now I will show you the most interesting thing. You can take a correctly dimensioned ceramic permanent magnet, and it's a permanent magnet, and I can tune the inductance of this system with the addition of the permanent magnet, and watch how bright that will get. Not sure if the video is capturing that properly, but this gets significantly brighter with the addition of my tuning magnet, and the negative resistance effect is still present. I can now connect this to a little light bulb here, a little 5 watt. He got so bright it almost turned black inside a little bit. So I'll connect that up and show you there's real power here that can do work. And that's very bright. Almost wants to burst. And I'll move my tuning magnet and just show you how much of a role that played. So again, tuning magnet. And I'll slide it gradually along the coil until we get maximum output. Which seems to be right there. So you're fully seeing it for yourself. We can also run motors with this thing. I'll connect a motor. So I'm showing you that the negative resistance output can perform real work. It can do fast recharging of batteries or whatever we want. It can run lights, do work. And if you hook up the correct value capacitor, I know the exact one by heart. It's I believe it's this one. If you connect up the correct value capacitor, it'll run quicker. This was just a bare bones setup for the video to show you. If I connect the correct value capacitor, the motor will run faster while drawing less power. Hopefully I can show that on the meter. Yeah, right there, look at the meter. I'm gonna try and show this without my big ass hand being in the way. But, so I connect the capacitor. Our motor is running at a higher power at very low input. And that gets me to think, why not have a motor generator combo and experiment with that? Because this effect is doing something very interesting to our motor. You can hear it picking up speed when I hold the capacitor there, and we're drawing almost no power, and we still have enhanced wireless power we can play with. And yeah, figured I'd demonstrate that. And the addition of that magnet there really helps for some reason, which is unknown to me at the moment. So next, I'll shut it off, hook up the hook up the ringer circuit to my DC power supply, along with the motor, so we can see the wattage draw from it. So next, I will move right here. We will connect up the ringer circuit will be powered off my DC power supply now. So we are drawing, I'd like this to face us. Well, it doesn't matter. So we are drawing 4.3 watts from our power supply, and if I connect that capacitor, watch what happens. Our motor speeds up drastically, and we consume half the power. That might be a little over 2 watts, I'm not sure. So why not have that motor connected to the output of a generator shaft and see what happens. The addition of that capacitor speeds the motor up and causes us to use less power. Also, the effect is really noticeable when tapping off just one leg of the coil. Now the motor's sped up and we're drawing 1.5 watts. Hopefully you can hear and see that. Drawing 1.5 watts from the DC power supply to run the motor as probably efficiently as possible. So next I will disconnect the ringer from the power supply. And we will hook it back up to what it was normally run off of, the battery. So it will be hooked back up again. Give you a good look at everything. Just have our multimeter connected here so we can read the charge. This thing almost remains fully charged all the time. Turn you on. Introduce the tuning magnet. Which greatly enhances the output. And like I said, that motor really benefits from the capacitor. Like, watch our power draw. I'm going to zoom in on that. So there's our power draw without the capacitor. The power draw with the capacitor. Drops to almost nothing. So yeah, that's that. And I hope that clears up some questions. I hold nothing back, nothing's locked behind a paywall. If you watch the entirety of this video, you can construct the system no problem. And yeah, thank you to everyone, all the supporters, the community. Wouldn't be here without all you guys. Feel free to replicate it, experiment. Join the Patreon, even if it's just for free. And yeah, thank you everybody. And we wouldn't be here without all your support.